Section 2.1, Quadratic Functions. Some terms that you're going to need to know for this chapter. First one, a quadratic function. We've talked a lot about quadratic functions already this year. Quadratic function means that we're dealing with a degree 2 equation. F of x equals ax squared plus bx plus c. A cannot be 0. If we look at this and a was 0, that would knock that squared term out, and now we would be down to a linear function, so a cannot be 0 in that form. Standard form. This is slightly different than what the book is going to talk about. This is the form that I will expect to see it in on your homework, on your quiz, and on the test. Standard form, f of x minus k equals a times x minus h squared. In that form, the vertex is at the ordered pair hk. So we look at what's being added or subtracted from the x-coordinate, what's being added or subtracted from the y-coordinate. Remember, f of x is y. And we take the opposite of each of those. Those become the vertex coordinates then for the vertex of our parabola. If a is positive, then the parabola opens up. If a is negative, then the parabola opens down. And the last thing that we are going to be listing is the equation for the axis of symmetry. Axis of symmetry is the line passing through the vertex splitting the parabola in half. So we're just going to go through a few graphs here today, list some things, and then that'll be it for the first half of 2.1 here. Graph y equals 1/3 x squared. The first question you always need to ask yourself is our function in standard form? In other words, looking back here, if there's a constant, is it over here with y? Is our lead coefficient factored out in front of our squared stuff? If it is, it's in standard form. So in this case, we are in standard form. So we can move ahead right away, identify the vertex. Vertex is going to be at 0, 0. There's nothing being added or subtracted from x, nothing being added or subtracted from y. This opens up. We can find both intercepts, x and y, which you will have to do for almost every graph you do in here all year long. X-intercept, put in 0 for y. We're going to get out the ordered pair 0, 0. Same thing when we put 0 in for x, and we should have known that from looking at our vertex anyway. The last thing that we're going to list for today is the axis of symmetry. Let's come back and list that after we get our graph started here. So the only point we know right now on our graph is 0, 0. It's the x-intercept, y-intercept, vertex. We don't know any other points. Since we don't know any other points, let's go ahead and pick a couple other values of x and see what we get out for y. Let's pick values that are going to spread our graph out a little bit. If I put in 3 for x, 3 squared is 9. 9 times a third is 3. If I put in negative 3 for x, negative 3 squared is 9. Times a third is also 3. So I have another point at 3, 3. And at negative 3, 3. Go ahead and connect those points then with a smooth curve for your parabola. There's our parabola. Again, I stop it as soon as I get through the last point that we have graphed accurately. You don't need to fill up the entire coordinate plane. And now the last thing, our axis of symmetry, is always this line passing through the vertex, splitting the parabola in half. If it is a parabola opening up or down, that equation will always be of the form x equals, because it will be a vertical line, and in this case, it's x equals 0. Second one, g of x equals 2x squared. Again, we're already in standard form. Once again, we can identify the vertex right away. We know that this parabola, again, opens up because a is positive, 2. We can again identify the x And y-intercepts pretty easily here. Both, again, are going to be at 0, 0. Last thing, our axis symmetry. Again, going to the graph, the only point we know for sure is right there at 0, 0. Let's once again pick a couple of values of x. Plug in. This time, if I put in 1 for x, I'm going to get out 2. If I put in -1 for x, I'm also going to get out 2. So there's our parabola. Notice the only difference between that one and the first one was our coefficient. And if you remember transformations, if that lead coefficient's absolute value is between 0 and 1, it's going to shrink it horizontally or vertically, making it wider. If it is greater than 1, it stretches it vertically, making it more narrow. And again, our axis of symmetry, passing right down the middle here, is at x equals 0. Okay, letter C. And this is going to be where some of you struggle the most with this, is identifying, is this in standard form? Okay, because if it isn't in standard form, then we're going to need to complete the square. How you are going to know whether or not you have to complete the square is if there is an x term in the function. If there is an x term, you must complete the square in order to get to standard form. If there is no x term, you should never have to complete the square to get to standard form. In this case, we just want to move the constant over with y. There is our standard form. Once you have standard form, begin identifying everything you need to. Vertex is going to be the ordered pair 0, 1. Nothing is being added or subtracted from x. Take the opposite of what's being added or subtracted from y. That's how we get +1. This time our parabola opens down. And let's go ahead and find our intercepts. X-intercept, we plug in 0 for y. When I plug in 0 for y, we get -1 equals -x squared. Finish solving, we get ±1. So there is our x-intercepts, 2 of them. ±1 and 0. Y-intercept, plug in 0 for x. If I do that up top here in this equation, put 0 in for x, we're left with 1 for y. Axis of symmetry, we'll do after we graph here again. So this time we know 3 different points. We know we have a point at 0, 1. We know we have points at 1, 0 and -1, 0. So there's our 3 points. That's really all we need to graph here to get this parabola. Again, we do not need to go beyond those points, so I'm just going to stop once I get beyond each of those 2 points, put an arrow showing it goes on forever in both directions. Now come back, identify our axis of symmetry going right down the middle here at x equals 0. Okay, looking at some now here where we do need to complete the square. Again, the reason I would know in looking at this that I need to complete the square is because there is an x term. Now you need to remember the steps in completing the square that we talked about back in the appendix section that we reviewed from Algebra 2. To complete the square, we want to move the constant to the other side of the equation. Lead coefficient has to be 1. If it's not, remember we factor that out. In this case, it is 1. So now we can complete the square. Take half of -4. Half of -4 is -2. -2 squared is 4. So I add 4 to both sides. F of x plus 6 equals, remember this always factors the half the middle term, which was -2. There's standard form. Once you get to standard form, everything else should be relatively straightforward as far as what you are finding. In this case, begin with the vertex. Vertex is going to be at 2, -6, opposite of what's being added or subtracted from x and y. This parabola opens down. Let's go ahead and find our intercepts. X-intercept and y-intercept. Y-intercept is going to be easiest to plug into the top equation here. If I put 0 in for x, we get out -2. X-intercept, it's easiest to plug in into your standard form. So if I plug in right there and I put 0 in for f of x or y, we get 6 equals x minus 2 squared. Take the square root of both sides. We get x equals 2 plus or minus root 6. Those are the exact values of our x-intercepts. The last thing we need to list for today is the axis of symmetry. Again, we'll get that after we do our graph. So vertex is at 2, -6 over 2, down 6. Our y-intercept is at 0, -2. Our x-intercepts, go ahead and plug those into your calculator to get the decimal approximations. So take 2 plus root 6 in your calculator. Take 2 minus root 6 in your calculator. You get about -1/2 approximately, and approximately 4.5. Because the vertex is here and it's opening up, we know right away there's our axis of symmetry. So let's go ahead and mark that at x equals 2. We also can plot another point on the other side here. If this is the axis of symmetry, that means we have to have a mirror point on the other side right here. There's 5 good points for us to sketch our parabola. Make sure for all intercepts you are given exact values. If you don't solve this algebraically, your calculator is only going to give you decimal approximations. That will not be good enough on a quiz or a test. Letter B. Okay, once again here, we need to complete the square to get this to standard form. The reason I know we need to complete the square is because there's an x term. 2 preliminary steps every single time that you need to complete the square. Move the constant over with y. Factor out the lead coefficient. So I'm going to take a -2 out, which leaves us with x squared plus 2x. Now we complete the square on what's left inside here. Take half of 2. Half of 2 is 1. 1 squared is 1. To the other side, I need to subtract 2 because of this 2, -2, that's out front here. Simplify, we get f of x minus 3 equals -2 times x plus 1 squared. There's standard form. Again, you have to be able to get to standard form. If you can't get to standard form, it's going to be very difficult for you to identify everything else. Vertex. Is that the ordered pair -1, 3? This parabola opens down. And let's go ahead and find the intercepts, x and y, as well as the axis of symmetry. Again, for the y-intercept, we want to look at the top equation here. Plug 0 in for x, we get out 1. X-intercept now here is going to be a little bit more involved. For the x-intercept, remember we want to plug into our standard form. Let's go ahead and do that. Put 0 in here for y, we're left with -3 equals -2 times x plus 1 squared. And to solve this equation for x, so divide by -2. Take the square root of both sides. Subtract the 1 over. -1 plus or minus. When we rationalize this, multiply by √2 over √2, we get √6 over 2. So there are our 2 x-intercepts at -1 plus or minus √6 over 2, comma 0. Begin graphing. Vertex, -1, up 3. Y-intercept, 0, 1. Because this is the vertex and it's opening down. We know that that's our axis of symmetry, which means I'm going to have a mirror point right over here. Then go ahead and use your calculator to get the decimal approximation here. So take -1 plus the square root of 6 divided by 2, and do the same thing minus. We get about 0.2 and -2.2. Connect those points. There's your parabola. Axis of symmetry, last thing we need to identify is that x equals -1. Last one. Again, first question is, do we need to complete the square? Answer is yes, because we have an x term. Get it set up to complete the square. Move the constant. Factor out the lead coefficient. Now we're set up to complete the square there. Half of -6 is -3. -3 squared is 9. To the other side, I need to subtract 9 because of this negative factored out front. We get f of x minus 1 equals the opposite of x minus 3 squared. There, again, is standard form. Vertex. Vertex is at 3, 1. This parabola opens down. Need to find the intercepts and the axis of symmetry. Y-intercept, easiest to find. Plug in right here, 0 for x, we get out. -8. X-intercept, put 0 in for y. Again, we want to do that in our standard form. So we get -1 equals negative x minus 3 squared, divide. Take the square root of both sides. Add the 3 over, we get 3 plus or minus 1, which is 4 and 2. So 4, 0, 2, 0. Let's go ahead and graph all these points we know. Vertex at 3, 1. Y-intercept at 4, 0 and 2, 0. Y-intercept at 0, -8. Way down here. Axis of symmetry, again splitting this in half through the vertex. So we know we have to have a mirror point 3 units away down here. Now connect those points as best you can with your parabola. Axis of symmetry, last thing in this time is the line x equals 3.